All right, welcome to day two of Intro to Coding Live. We, I believe we have a handful of brand new students today that weren't able to make it on day one. Um, so very briefly, if this is your very first day and you did not see the recording from Monday and you did not go through the info session or see the info session, um, I want you guys to please um, drop a message in the chat to let me know. But essentially, if you have no idea what's going on right now, this is your first day. The very first thing that I need you guys to do is to get a GitHub account, right? That is GITHUB, GitHub, right? GitHub is where our curriculum lives, and it is what we are using to ensure we can run some code. So you're gonna require that. But once again, if you are new today and you have no idea how we're gonna run the code or where the curriculum is at, or you have not installed CodeSpace, please drop your name in the chat so I'm aware of that. But without further ado, let's get started and jump straight into where we left off yesterday, which was lesson one. Right, we were about, I want to say, two-thirds, almost three-fourths of the way done with lesson one. I think the last thing we covered yesterday was reverse strings. Um, Okay. I see your message, Tiff. Awesome. So really, the whole point of the curriculum is so you can either follow along and run the code, or as well to practice the exercises on your own, right? But at the end of the day, all you need to know is, you need a code editor. You need something to run code, and just being able to read the exercises. So you don't need necessarily have to have a GitHub account. Really, you can just click the link to go to GitHub and click on the files on the GitHub repository and read what the exercises are doing. And if you can literally run code in Notepad++. So whatever you have to run code, that works fine too. Um, Ev Ewa, is that how you pronounce your name? I'm sorry. I hope I'm not butchering it. Ewa, is that correct?
Yeah, yes, it's fine. Yes, thank you.
Yeah, yeah. Oh, awesome. That's good. As long as you have GitHub account and CodeSpace is open up with the curriculum, that's good. Really, we're going to go ahead and just read through the curriculum. We'll talk about it, and then I'll show you different versions of how to do stuff. And uh, I emphasize that if you have any questions, stop me in my tracks and ask. Right? I don't think it is rude at all. Even if I'm mid speech, stop me and ask the question before I move forward because I do not want to confuse anybody. I talk fast sometimes, and if you hold on for a question, I might be two subjects ahead. So if you have any questions, just stop me, come off mic, and let me know. But all right, we should all be seeing the my code space, I believe. Yeah. So yesterday we ended up leaving off with reversing a string. The next part of lesson one was talking about methods, right? So all these methods that you're going to see here are pre-built with Python, right? So when you guys install Python, you pretty much essentially had access to most of these methods that you're going to see here. We will see some methods later on in the course that aren't necessarily already in your Python code. You really have to kind of, maybe they are installed in your computer, but you essentially have to import them into a file to utilize those. Um, for those of you who've been around Python, you might be familiar with like random or the math module or stuff like that, right? So, for the most part, these methods already come with your code, so you can use them as needed. And the reason for that is because they're, very common functionality that people like to use, so they are built in, right? So the very first one that you're going to see here is going to be used to see the dot upper method, right? The dot upper. All right, so there are some methods that you have easily accessible to you guys that's going to make your life so much easier, right? Um, so the dot upper method allows you to convert the characters in a string to uppercase. And we see that here, right? We have the string of hello world, right? It's all lowercase. And I want to point out something as well. When we try to capitalize this text variable using the dot upper method, uh, they're creating a different variable so they can actually change it. If I'm pretty sure you can't. I mean, you could, but you could see both the old version and the new version here, um, right? So you can print both the older text and the new upper text back to back so you can see what it shows you. But the dot upper method is going to allow you to automatically capitalize everything um, inside of a string. Now, this is very helpful for certain reasons. Not necessarily the upper method, but I would say the dot lower is a very helpful method. So the same way that you're able to capitalize all the characters in a string, you can do the opposite in lowercase them, right? And this is helpful because sometimes you're gonna get, some form of text that might not always be in the same format, right? So it's easy to work with strings or with large pieces of data if you know that everything is all lowercase, right? Because in the event that you're getting different types of data, you would have to ensure that you can work with it all. And if there is something out there that has capital letters or isn't formatted like the rest of it, your code might miss it, or you might not catch it, right? So you'll learn that there's gonna be some events where you're gonna want everything to be like items with like items, right? So all the same, everything formatted, either no spaces or all lowercase. And the dot lower and the dot upper method allows you to just make everything the same, right? So whether you want to capitalize it all or you want to lowercase it all, right? So both of these are essentially just two different sides of the same coin, right? You can do capitalization or lowercase.
Hey Roger, I got a question about that. When I was looking over these, I was wondering, so obviously that applies it to the entire string. Can you apply it, like, is there a way to add an index to that to capitalize certain pieces of it or lowercase certain pieces?
Mm, Not necessarily.
Like maybe if you want, if it was all lowercase, if you wanted to just uppercase the first letter of every word or something like that.
Um, Not necessarily. There's a way to do it, but not how you are insinuating. Who can guess why?
Because we can't break apart a string.
You can break apart a string, but you can't change a string, right? You can't necessarily mutate a string. So really, you think here that this is actually changing the string. This is creating a whole new string. Right? Don't get that confused. It looks like magic, right? You might think there's a wizard behind your computer doing this. There isn't, right? This is actually creating a whole different string and reassigning it to the same variable. So what you just implied, right? You were like, can we change, um, could I add an index and change one specific letter? No, right? Because by adding an index, you're specifying a specific point in the string, therefore you're trying to mutate it, so it wouldn't necessarily work that way. Now, if you did want to do it that way, David, you want to split it up, the string. And there is a method for that. And I'll show you in a little bit. But yes, there is a way to do that, but not with this specific method.
Okay, perfect.
Yeah,
Thank you.
yeah, no problem. So the next one is capitalization, right? So um, we can either capitalize everything uh, using the dot title, lowercase it all using the dot lower, or we can use the capitalized one to capitalize the very first word, right? Oh, I'm sorry, I misspoke. I meant to say dot upper. I read the next one by accident. All right, so dot upper makes everything in caps. Dot lower is all lowercase. The capitalize is going to capitalize the first letter inside of your string, right? Here you see Python programming, right? Two different words. They invoke the dot capitalize method on it, and they assign whatever comes back from this into this new variable called capitalized text, right? And that gives you Python programming. Notice that we created an additional extra variable to do this. The variable text still exists, right? It didn't go anywhere, right? Because we're not changing it.
So I actually have a question. Is this going to be the case for like all the different string methods, or are there certain string methods where you actually can change the original string itself?
No string can change. Strings are immutable. That is like, what's the best way to explain it? It's kind of like the the laws of energy, right? You can't make or create energy. Same thing, right? You can't change the string. That's it. Immutable. So there's not going to be a single method that changes a string, right? The basic concept here is that strings are not changeable. You are recreating a new string, right? Uh,
Like modifying it attached to
you
a different variable.
you are essentially saying, hey, actually, let me put it this way. If I was looking at this, this is saying grab this string and make a copy of it. And this copy of it, make sure it's all capitalized. And then save that copy into capitalized text. That is literally what this is saying, right?
Save it or print it.
It's saving it, right? The equal sign shows assignment, right? So we are assigning this to what's on the left, right? Afterwards, we print it here on line 4, right, with the print statement, right? But the equal sign shows assignment. So whenever you see this, right, the left side is typically the variable you're trying to assign to, and everything on the right is what you're assigning to it, right? So this is your box. This is the content that you're gonna put in the box, right? And then this is you displaying your box. Make sense?
Okay.
So we saw dot upper, we saw dot lower, we saw dot capitalized, but we also have dot title, right? The name title means that it's going to capitalize it like you would like a movie title, right? Hence the name title, right? So although there are spaces in the string, when we invoke the dot title method with the text variable, it's going to capitalize every individual word, right? What's happening inside of your computer is grabbing the string, making a copy of it, going through the string individually, finding all the words that are separated by spaces, and then capitalizing each word.
So that's the
That's
one David asked about earlier, right?
David asked for just one specific word capitalized or one specific letter capitalized inside of a string. If his question was, can I capitalize the beginning of each word throughout my string? Then yes, that would be the answer. But no, David
Yeah.
specifically
Yeah, I think at
mentioned.
one point I did say that, so
Did
she
you?
is right. It would be titled, but also you're right. I was referring to being able to capitalize just any part of it that you wanted to. Or
Okay.
initially, that was my question.
Yeah. So this is one this is one way of doing that. If you wanted to grab one specific item, uh, then you would have to go through every individual character inside of that string to find it. And then you would want to change it, but assign it to a different variable because you wouldn't be able to change it in place, right? Because you can't change strings. Dot strip. Here's another helpful method that you guys are going to find very useful. The dot strip method is going to remove any white space around your string, right? And here's a prime example of that, right? This variable called text, it has a string, but what you see here highlighted green, this is all empty space. Now remember, spaces count as characters. So although there is all this space, this counts as part of the string. right? The first space is index 0, index 1, index 2, index 3, and so on and so forth, right? White space or characters 2. Well, the dot strip method can allow you to remove all the extra space from the left and from the right of your string. All right, so we invoke the dot strip method, and then we assign the result to a new variable called strip text, right? And it removes the spacing, the extra space to the left and to the right. Now you might be asking, well, Roger, when would this even be useful for me? Who here knows what CSVs are? Todd?
The
Okay. Yeah,
Excel. Oh,
yeah. Go ahead, Jose. What are CSVs?
just the Excel file. It's just the CSV is the extension file name of an Excel, or that you can use in like Google Sheets or Excel.
Not specifically Excel, right? Because Excel, I think the extension is XLSC or something like that. But it
That's
stands for
right.
comma separated values, right? So it is a form of a file, yes. And typically you could convert. Excel does allow you to convert the Excel spreadsheets into CSVs because they convert pretty nicely. So I'm assuming that's where you're grabbing it from. But yes, you're fairly close. They're comma separated values, hence the acronym of CSV. Um, uh, so CSV files sometimes have empty spacing. .txt files, right? So like your notepad files, these basic text files, when you go to the next line, all that spacing to the right, all that is white space. And if you try to import data from some of these files, it's going to quite literally take all that spacing to the right of it as white space. And you're going to see some weird functionality. So if, when working with files in Python, the dot strip method will allow you to kind of format some of the data that you're trying to import into your programs. So that's something to keep in mind. That'll make more sense once you guys get into the program. If you guys go through the other program I teach, Foundations of Programming, we work with files, and I'll show you how to do that too. And then you'll also do it in the first 2 weeks of the immersive program. I can't really speak too much about the other ones because I never taught those, but yeah. So this is something that's very common, right? Reading and writing with files, or reading and writing files with Python. The dot strip method is a nice method to know. The next method here is going to be the starts with, right? A check if a string starts with a specific prefix. Here we have the text of hello world. They invoke the starts with method to it, and they pass in the string that they're trying to see that it starts with, right? You guys have probably seen a common trend too here, right? Whenever you're trying to use a method, right, you have to call the item you're trying to use the method on, and then follow it with the dot and the method type, right? So you would say text dot and then whatever method you're trying to use. So this is a trend that you're going to see for the rest of your time in Python. This is how you're going to use methods on certain things, right? When I say invoke, um, I'm pretty much just saying that the text is calling this method. It is using this, right? It is using this method. And it's using the method, and it takes a string in. Now you might be wondering, like, Roger, how do you know all this stuff, right? There's so many methods right now. I feel a little overwhelmed, right? It's only been 15 minutes of class, but you already talked about like 8 different methods, and they all take different things. Uh, you don't have to memorize all these, right? These are the most common methods that you will see in Python, which is why we are covering them. Really, this intro to coding class, what we're trying to do is expose you to enough information to allow you to know that this information does exist. So when you guys are going through your exercises, your problems, and you encounter a point in your exercise like, dang, I wish I could do this. Like, how can I how can I break this string apart to do this? Like, this problem wants me to grab the start of a string and replace it with something, but how can I see what's at the beginning of the string, right? I remember Roger talking about this specific method that does it, and then, it could lead you down the proper path to finding an answer. So, if you feel a little overwhelmed with the classes and all the stuff that we talk about, don't. Just kind of listen to it. I'll tell you the ones that are going to be very helpful. Maybe you could put those in the back of your pocket. But these are pretty much everything that we cover here is going to be the most common ones, and then I'll tell you like the ones that are going to be like your best friends, right? So, start with is okay. I've only used it a handful of times, but it does allow you to check for a specific string that starts with pattern, right? You could use this method. You'll find much more powerful ways of doing this. If anybody's ever heard of regular expressions, regex is the short term or short name for it. There's other more effective ways to looking through a string for a specific like substring. But this is a very simple way of doing it. So you could use a start with, and you see here that it's going to return true, right? So when we invoke the starts with method to the text of hello, it's going to return true because hello did successfully uh get caught within here, right? It does exist, therefore it's going to return a boolean to us.
And what makes this or I guess Boolean where because this one is where I'm kind of confused. So how does it make it a Boolean where it returns it true or prints it true? Is it just that's the way
It's built,
is
yes.
it the starts with is really like a Boolean question? Does this string start with hello? If so, then return true
That's a
kind
good
of deal
that's a
or
good question. What are methods? Who can tell me what a method is? Anyone can guess?
A filter or a
No,
function?
a function. It is a function, right? We haven't talked about functions yet, but it's really just a function, right? The name is it's a little bit different because how it's built under the hood, right? And deep in its code. But method really is just a fancy word for a function. To be more precise, a method is a function of a class, but really a method is just a function, right? And functions do things. Now, once we get into talking about functions, which if I'm correct, if actually today, if we get to it, we should be able to. Functions, you're able to define them. You can tell the function how it should work, right? You can build a function that adds numbers. Someone has a hot mic. You can make a function that searches through files. You can make a function that does anything really. Functions, you make them do stuff for you, right? Um, and when you define a function, you are the person who sets the rules of how this function should work. You define what the function should take and what the function needs to return, right? So it's no coincidence that I have to pass in a string for this to work. Whoever created this function made it so, like, hey, this has to take a string and it's going to return to you a Boolean. Now, if you want to see a little bit more of where this method or quote unquote function is created, you can right click it and you should be able to press go to declaration. And it's going to show you where in your Python file it's being defined. And it's going to go over your head. I know some of you guys are looking at it like, yo, what the heck am I looking at? Right? But this is like the code of Python, right? Someone wrote Python. Python was invented by somebody. Someone had to manually write this language. So someone created the language of Python. This is not just magic, right? So all these methods that we're using, someone actually created them and then added them to the language of Python and gave us access to them. Why? Because these are things that people were often using and found that they were needing to do very commonly or very often. So we're like, okay, well, this is something that the community likes to use or do. Why don't we just build a method for it so it's readily available to everybody? All right, that's kind of how the thought process goes. So
Is
these are
that
all,
is that where the different versions come from as they add to the
yes,
actual system?
absolutely, yes. So, as a new version of Python comes out, there might be some new methods that come out that do different things. Some other methods that aren't used as often or no longer needed. or get deprecated, right? Sometimes your VS Code can catch it too. They'll tell you like, hey, this function is no longer in use or whatever, or what this piece of code, right? That was like that's outdated from version so on and so forth. But yeah, you're absolutely right, David. That's how that works, right? So whoever defined this was said they made it so it's supposed to return a Boolean to you to let you know if it found the string or not. Make sense?
Okay, that makes sense. So it's kind of like the way Python was written.
Yes.
Um, it that method kind of prints out the Boolean to you. Okay.
Yes, that's
All
how it
right.
was
Appreciate
created.
it.
Whoever wrote it. Yeah, absolutely. Awesome. So just like we had the opposite of upper, which was lower, we also have the opposite of starts with, which, as you may guess, it's ends with, right? So you're able to check if a string ends with a specific substring like world, and just like the one before, it'll return true or false to you. All right.
Hey
Another.
Roger,
Hi,
sorry to
Sarah.
interrupt.
It's okay.
Um, does this mean that if you have numerous lines of code of Python where there's, different versions of hello world, it's like goodbye world or anything else, will it bring back, if you have more than two, or if you have more than one, will it bring back true still? Like if I'm writing
Um,
something fully and it says hello world and goodbye world, will it still be true?
the moment it finds hello the first time, it'll return true.
Okay.
Does
The
it?
first time.
Yes, the first time. It's
Okay.
gonna find if it exists. And you'll see what I mean a bit. There's some other functions that return to you multiple occurrences of stuff, or how many times it occurs. Did that answer your question, or did I misunderstand?
No, you answered my question. It made me think of does this mean that it's also the case when you input something like find? It'll always just bring back the first one?
Yes. Um, fine. This one returns zero because we don't. It doesn't have. No, hold on. Seven. Yeah, this is wrong. Why was I saying zero? Yes, but notice that is appears twice for the final one, but it returns seven to you. What do you think the seven is?
If I'm guessing, then I would say it's the index number of where it finds it.
Absolutely, yes. It's gonna return to you where it found it. But it doesn't tell you about the second is. It's only gonna tell you the first one. Now, if I'm correct, I think the find has additional arguments you could find. Let's go to W3 schools. I don't use the find method too often, but some of these methods give you optional parameters that you can pass in. In the event that you want to change how it works, right? Um, for example, here is this one, the find method. Uh, so look at the find. Requires the value to search for, optional where to start the search, where to end the search. Okay, this one doesn't do it. But there are some that allow you to pass in an argument where it's like, hey, like I want you to return the first three occurrences, so the first five, right? I only return one. Um, it's these much more basic functions don't have them, but as you'll see later on, when you guys get into like regular expressions, you get a little bit more functionality with some of these methods. Um, but yes, it's gonna vary on the method really. It's gonna be method dependent. So, just like I mentioned, which really just brought me to the next topic of conversation, which was the find method, right? We can look for a substring within the string. So we invoke the dot find method on the text variable, and we pass in the string of is, and we see here, I don't know why I say zero. This is supposed to be the index. It returns seven, right? Uh, seven because that's the start of the first is that it found, right? At index seven. And just like I mentioned before, there's two uh versions of is in here, but it only returned the very first one.
So
Here's
shouldn't
a
it say result two? Like it found two?
Negatron, Batman, this is going to return to you where it finds the first occurrence. That's it. Uh, there is another method that does that. It's going to tell you how many times it finds it. This one does not.
Okay.
Right? This specific method is only going to find the first occurrence of the item you passed in. I hope I didn't confuse you guys by bringing the other one up. Um, but yes, this one will return to you the first occurrence. To be completely honest with you, Myra, I don't use this method often, so you don't have to worry too much about this one. Just know that there is a method that could do this if you ever found yourself needing this. Sound good? And actually, to add upon that, Myra, because that the fact that it only returns to me the first occurrence of where it finds it makes it a very, I would personally, I would say, makes it a very useless method. I would say I would rather manually code for me to go through the entire string and find every single one than use this method. Like I said, I'm exposing you guys to different methods out there so you're aware of what's available to you. But personally, it's a pretty weak method. Unlike this next bad boy in here, the dot count. This is pretty good. Counts the number of non-overlapping occurrences of a substring in a string, right? So we saw the dot find, which is pretty, mid. The dot count is going to tell you how many times something does appear, right? So here is that same text. Python is a popular language and Python is versatile. Instead of looking for is using the dot find, we use the dot count method, which we pass in. Well, this time it wasn't the is, but we were passing in the text of Python, right? And this is supposed to return to you how many times it found it within the string, and so it does, right? So two of them, absolutely. All right, so this is a pretty cool one. I actually use them very often, I would say, throughout my time coding. So the dot count one is definitely one that you might want to keep in the back of your mind. It would come in handy. Now, uh, just as a disclaimer, for some of you guys that like to ask some of these other questions that are a little bit more advanced, um, you might, for those of you who are already thinking ahead, like about how effective is your code? Is my code running as effective as I would like for it to be? For those of you who know what I'm about to say, whoever knows what big O notation is, and if you don't, that's okay. Don't worry about it. You don't have to know it right now. Uh, but if you're thinking about big O notation, you're thinking about iterations of for loops and how that may increase your time complexity. Uh, Methods like dot count increase your time complexity. All these methods I'm showing you guys, there's actual code that goes behind these methods, right? It's not just magic. What do you guys think the dot count method is doing under the hood? It's iterating through every single character in a string, individually, one by one, until it finds what you asked of it. And then when it finds it, it's going to save it to the side. So when it's done looking, it's going to give you the answer you asked of. Right? So it's not just magic. It doesn't just automatically know where these things are. There is actual code that's running in your computer, but you don't visually see. So just be aware of that. As you guys go further into your time here with Platoon, and you start thinking about like, is my code as fast as it could be? If you're using methods like this very often within each other, uh, it's not as effective as you think. It looks nice, it looks sleek, right? Just use one method to do the hard work, but it's not as easy as you think it is. So we have the dot count one. The dot replace is an interesting one. The dot replace allows you to replace all the occurrences of a specified substring. Now, notice that I am assigning this to a different variable to do this. Right? We have a string here called date string, right? Which is just a string, some kind of date format, right? The month of March. I'm going to call this string, and I'm going to invoke the dot replace method. Now, if you want to learn more about the dot replace method, you can go to W2 Schools. But really, you can hover over these, and most times, if it's a built-in method, you would see something like you're seeing now. It's going to open up for you a small description of what the method should be doing, right? And we see here that it returns a copy with all occurrences of its substring of old replaced by new, right? And then at the very top, the top section of this square, you see that the definition of replace, it's going to take an old variable and a new variable, right? Um, so usually, and you'll get better at reading this with time. Uh, if you have a method, you can typically see what the method does by hovering over it. Now, if this is your first time seeing code, this might look very, foreign, might look like hieroglyphics, and that's okay. It looked like that for me too for like months. So don't worry about it. You honestly, when it comes to some of this code, you only get better by looking at it over and over again. So it comes with time, I promise y'all. But so they're essentially taking the ode, right? Which is they're going to replace the forward slash that is already here. And here's the new, which is going to be the hyphen, right? And then we're able to print out both the old version and the new version to be able to compare and contrast here. And you see here that we successfully replaced the forward slash with the hyphen, right? Notice that we did this to a different variable, right? Because we can't uh, replace a string. I don't even think it'll work if I do something like, actually it might, but I think it's just going to replace it. Dot replace. Let me see if I can do this. Okay. It's already yelling at me. Oh, date. And I can't spell to save my life. Let's see if I don't get an error. Well, I didn't get an error. But know that this didn't change the string. These are two different strings. It reassigned it. It grabbed the old string, it invoked the method on it, and it reassigned the new value to the same name. So although we didn't get a message, just know that under the hood, it's not changing the original one. It's creating a brand new one, right? And if you're curious to how that works, you can invoke the ID method that I showed you guys yesterday to see how that really changes. So here's another important method to know, the dot split method. The dot split method allows you to quite literally split a string apart. So someone brought it up earlier, I believe it was David, right? About not being able to split strings. We actually can, right? The dot split method allows you to do that, right? It splits a string into a list of substrings based on a specific delimiter, right? Delimiter, for those of you who are ESL, hello, me, means, where you want to split it up, right? So you want to pass in where in the string should it be broken apart in. So we want to split up date string. We're going to invoke the dot split method, and we're passing in where we want to split it at. So we're going to split it at the forward slash, and then the result is going to be a list. And I know you guys don't know lists yet, and that's okay, right? Don't pay too much attention to the list. Just know that it will split it up into quite literally a list of 3 different strings, right? So it does create 3 different strings, right? You also lose whatever you split it at, right? So notice that there's no forward slash in either one of these strings, right? So wherever it splits it at, it removes it, and now we have 3 individual strings saved into this list. So if you find yourself trying to split a string apart, let's say you have a sentence, right? And you wanted to grab every single word and save it somewhere. You could use the dot split method. Carry, nice dog. You could use the dot split method and split it at every space, and it would give you every single word from that sentence into a list. So that's a very helpful method to use, especially when you're just trying to work with the words and nothing else. You could literally split it at the spacing, and then you can work with each individual word individually. And then once you're done, which brings me to my next method, you can use the dot join method to bring all these words back together. All right, so the dot join method allows you to pass in an iterable, right, which is just another word of a list, right? You pass in a list to the method, and it's going to join it together. Now, this is one of the weird methods out here that I want you to notice. It looks different than your other methods. Here, unlike the dot split method, where you call the variable you're trying to split up, like just like everything else, we call the variable we're trying to use followed by the method we're trying to invoke on it. This was different. I don't know why they did it this way. But here they are putting what they want to join it with first, and then they use what they want to join it with to call the dot join method, and the dot join method is going to take in the variable you're trying to pass in. Right, so it's almost like backwards. I don't know why it's done like this. Right, don't complain to me, complain to Python. But this is how you join the string, right? So if you want to use the dot join method, you have to pass in what you want to join it with. And notice it is just two single quotes, right? There's no space in here. So I don't think it's gonna, yeah, there is no space. So notice here that the date that we split up, it's all conjoined together because they just quite literally put two single quotes. Now, what if I put in an at symbol in here? It's going to join it, every single item within this list, the split date, it's going to join it with the at symbol. Right? So you're able to take in a list of different strings and then join them together. If you want to make something into a sentence, then you would just leave this by with an open space, and it would join it with an open space. So that's how you can rejoin a one split string back to one single string, right? So the dot split and the dot join method are going to be one of your best friends when working and manipulating strings,
Hey,
right? So
Roger, I got a quick question.
I got a quick answer.
Maybe. On the split, all right, this may be irrelevant, but like when you did the join, for example, and there was no space and it gave you just essentially one integer, it was like 03142024.
Right.
If you were trying to split that up, I guess what I'm saying is if you were trying to do a split and there was no specific character you were trying to split the string at, is there a way to do that?
Yes, but now it becomes a little bit more complex, right? Because now you don't have anywhere to specify where you really want to split it at. So,
Like what if it was like every 2 digits or something like that, you wanted to add a space, like split it?
what would probably have to happen? I can't think of any built-in method that does it, but you would have to go through every single character, and after you go through every two characters, you grab those two characters and then split it off. Then you go to the next two characters and then you split it off. So you would have to iterate through every single character and split it at every two is really the best way I can think of because I'm trying to think of I don't think there's any built-in method that does that. So you might have to manually do it that way.
Okay, I was just curious. Thank you.
Yeah, let's see. For example, let me answer that question. Let me remove, where the hell did my ad go? Okay, let's go. I would say for num, it merge date print num. And I know this looks very confusing to you guys. That's okay. Right, look, I can go through every single number from that date, right? And then you would do something like this, but after every two numbers that you pass through, you would add it to a variable, and then you would, you know, follow it with a forward slash. Does that make sense?
Yeah, I get what you're getting at for
Right.
sure.
So you would have to manually do this. I can't think of any method off the top of my head that would do that for you if it doesn't know where you want it to split it at. That's a way of doing it. All right.
Got it.
Awesome. So these next ones, we're gonna go to them quickly for the sake of time because we need to start lesson two. But here is another method called is alpha. This allows you to check if everything in a string is an alphabet character, right? So this is a good way to check if something's a number or not, right? Or like if they have a number inside the string or their name. So like if you're trying to check someone's first name in like their account, make sure they actually put in a real name and they didn't add, numbers like I don't know, like Elon Musk kid or something. I don't know what he called them, but this is one way of doing it, right? So you can check, ensure that they actually gave them a proper name on their account or their last name. And then same thing, you could do that with the numbers. So if you want to ensure that the what they gave you is actually digits, then you could use is numeric, right? To ensure that when someone puts in their age, right, into like their sign form or whatever, it's not like spelled out. Like, I am like quote unquote, you know, 45 spelled out. I'm not telling you my age. But that's one way of doing it, right? So you can use is numeric or is alpha. Um, Also, if you're getting data from like your front end or your back end, something's very good to ensure you understand what the data is before you start working on it, right? I mentioned this before, I think yesterday, is that if you don't know what kind of data types you're getting back and you just immediately write code that starts multiplying and adding and dividing stuff and their strings, it's going to give you errors. So it would be good to check what your values are. So is numeric is a very good one to do that with to check if what you're getting back is a number or if it's an alphabet letter. This one checks for both alphabet letters or digits. So is alnum, that's another good one, right? Here you see it, ABC 1, 2, 3. When you invoke the is alnum, it returns true. And that's the next thing. These will return a Boolean to you, right? So is alnum, is numeric, is alpha, these return Booleans, right? It's going to be true or false if it passes or not. These are repeating is lower. Oh no, it's not repeating. This isn't changing it. This is checking it. Right. So the same way that we're able to check something with alphabet or numbers, this would check if something is all capitalized or if it's capitalized or it's lowercase, right? Um, so here this is all capitalized. Um, if we invoke the is slower, we see here that it's going to return false. Even if we remove the digits, I think it's smart enough to know that the digits aren't numbers, so it's not going to check it. But it returns false because ABC is obviously all capitalized, and the same thing with the is upper. All right, and the last thing we're going to cover here is going to be interpolated strings. I'm sorry, I kind of blazed through this last part here because we are already behind from yesterday. Um, and I'm assuming, honestly, I'm pretty sure a lot of you guys probably just finished this on your own without me anyway, so that's okay. But the next important thing that you guys should know is interpolated string, right? Um, String interpolation is typically what you'll also hear. Really, what that means is adding variables into your strings. All right. Why is that important? And I think I gave you guys the example. Let me know if I didn't. But if you had like a list of students, right? I think I gave you guys an example. And it was like Todd, I see Thomas, and I see Jose, right? And I wanted to greet you guys, right? Or send you a welcome letter to my course, or let's say I work at some kind of university and I'm sending out a bunch of welcome letters to everyone for that's coming in as a freshman. And I have this long, list of names of people who I should be sending an email to. This is how I would do that, right? I would grab this list and I would want to iterate through this list and send you guys some kind of message, right? Now, this isn't really too realistic, right? Because this is not how the code would look like, but this is how a good example, right? If I wanted to say, let's say, I want to say welcome to each one of you guys, I would iterate through each one of y'all. I would say for students and list of students, and I know we haven't talked about for loops, just bear with me. I would want to be able to pass in each student dynamically so I can send you guys all a message without having to manually say hello to each one of you guys. Right. So once again, what is string interpolation? String interpolation allows you to pass in variables into a string. So how do we do that? Well, to format a string to be able to take in these variables, we're going to use the F keyword here, which I think you guys can see. But you see here, there's an F. So you're going to prefix your string with the letter F. And the letter F quite literally just stands for formats, right? We are essentially telling Python, hey, I want you to format this string. And it lets it know that it might possibly have variables inside of here. Now, how does Python know how to interpret what is a variable and what isn't? Well, it does that by using the curly braces, right? So here we have, um, I got two variables, first name and last name, Jimmy Fallon, right? And then we have a greeting. I want to be able to pass in this name dynamically within my string and have it take the value that's already saved to the variable. So I type my string out, but in place of where the name and for the first and last should go to, I'm going to pass in the variable that is currently holding these values, right? And I do that by putting them within curly braces. Excuse me, I burped. That was very rude of me. But I'm going to put these variables within curly braces, right? That's going to allow your Python code to understand, okay, this isn't just raw text. This guy is passing in some variables. So I need to look into the variables and see what's these values within here and add this or format this into my string, right? And that's how that works. So this is very good to help you dynamically format a string without having to hard code each person's name or just hard code the information within the string. All right. And
A quick question about that.
quick
Not really
answer.
about that, but about the list. So I know you basically made a variable and you assigned it to a list of students. And then you said, for each student in the list, print the statement.
Sure.
Well, so if the word students in your code, if you replace that with anything, like an I or an N, or would it still work? Why
Yes.
is the term students important? So it's not. It's
No.
just
Hold on, let me bring it back in because it's commented out. It's a placeholder. You give it a temporary name or a placeholder name so you can reference it so it knows who you're trying to talk about.
okay. So
Right?
for basically goes through each thing in the list, no matter
Yes,
what you put there.
it's a little out of scope, but my fault for bringing it up. Yes, essentially what I'm saying here in the line of code, and we'll talk more in depth about it, is for every student and list of students, do the following, right? once again, for every student, singular, in this list of students, plural, I want to do the following. Well, here, I already specified that each student is going to be referenced with the letter X. So as I iterate through this list of students, it knows as I grab each individual student, it's going to take the identity of the letter X. So therefore, I am able to reference each student with that letter. Does that make sense?
Yeah, it makes sense. Yeah.
Yeah. And it could be whatever your heart desires. It could be X, it could be O, you can call it pi. It doesn't matter. But usually you want to give it something very relevant, right? Relevant to the subject at hand. Right. If I'm gonna iterate through a list of students, then each iteration, I'm only grabbing one student, so why not just call it student, right? That gives me a better idea of what exactly my code is working with. So yes, it could be whatever you want it to be, but ideally give it a name that's fitting. Make sense?
Hey Roger, real quick, can you just tell us what that shorthand was that you just made that into a comment and then unmade it into a comment or undid the comment?
Yeah, control forward slash or command forward slash for you Mac boys.
Copy. Got it.
All right. So next and last thing, oh, I guess close to last thing. So that takes care of formatting. So what's another way that I can format strings? This is a much more common way. Um, you just learn the F string, but there's a much more basic way of formatting strings. All right, guys, not all at once. Relax. String concatenation, right? So really conjoining strings together. So what you could say, in the event you didn't want to use an F string, which doesn't make sense of why you wouldn't want to use it now that you know you could do this, you could say greeting is equal to, you would say hello, comma, space, and then you would join it with a plus sign. So first name plus a space. So I can have some space between my first and last name. Then I will say plus last name. And then I will do plus exclamation mark. And this will give me the exact same thing as the other one. Let me print reading.
Okay, I see now. So when you're saying there's many ways to write code, although there's not a right or wrong way, there's definitely more efficient ways
Yeah,
to write it.
absolutely. Right. So I showed you string interpolation, which is using the F string to format it, right? And then passing in variables within it. Or you could use string concatenation, which is you're essentially just adding them together, right? So here I'm specifying I want you to grab the string and I want you to join it with whatever saved inside the first name, followed by a space, followed by last name, followed by an exclamation mark. And this is going to quite literally give me the exact same thing as this was going to give me, right? And you see your same printout statement. But yes, to answer your question, Jose, yeah, absolutely. There's multiple ways of doing stuff in code. There's no right or wrong answer. Early, whatever path you guys decide to take, that's okay. As long as you understand what you're doing, that's really all we care about right now at your state of where you guys are at. As you guys progress through your time here, Platoon, you'll find much better and efficient ways of doing things, and that's okay. Now, before we go on break, lastly, I want to briefly cover escape sequences. I covered them very briefly yesterday, but you're able to simulate new lines, tabs in your strings. Uh, I think it was either Monica or Karen that asked this question, right? Um, but you could use single quotes or double quotes as well within your strings. You just have to escape it using escape sequence. And the escape sequence is just a fancy word for a backward slash, right? You put that within your string, and that's going to tell your Python code to treat it as such, right? So the multi-line, this is A, and then you see here there's a new line, which with the double quotes used as escape sequences. So here's the multi-line on the next line with the double quotes, and then the string, right? And then here, this is a tabbed, right, string. So you see how this works. So you could use escape sequences, absolutely. And that's going to be the first part of class. Let me go ahead and stop the recording right now, or pause.
I can't hear you. I'm not sure why.
Oh, I'm sorry. I was muted. To answer your question, David, next break, because we are a little bit behind schedule. Um, and then we can work on it. But all right, we're gonna pick up from where we left off, guys. So we finished, we talked about escape characters. The last thing here to really talk about is gonna be the none type. I mentioned it very briefly, right? So none type is a form of a data type, but really a much better explanation of what non-type is the absence of data, right? When there is nothing there, right? It doesn't necessarily mean zero, right? Really, it just means nothing. There's nothing there, right? And a good way of explaining that would be like think of an empty cell, right? No data within there. That's what that represents. None. And none is going to become important once we start talking about functions. Just be aware that the chances of none being um, a value that you see are pretty high, especially working with your functions. Because if you don't return something from a function, then you're going to get something like none. And it becomes important, especially when you have a function that's supposed to return, let's say, some kind of number, right? Let's say it's doing some math, but you forgot to return the total or whatever the result is, and then you try to add it, you're going to be trying to add quite literally nothing, and it won't work, or it won't give you the result you expected. And you're like, why this is not correct? And then come to realize that you have nothing, right? You're not returning any kind of data. And you'll see what I mean once we start talking about it in a bit. Additional exercises. So here at the bottom of each one of these lessons, you'll find a handful of exercises. When it comes to the exercises in each lesson, do not, I mean, you could, no one's stopping you. But I would say do not use concepts that haven't been covered yet, right? For example, you might be tempted to use a for loop, right? Or if you're familiar with lists or dictionaries or all this crazy other stuff on lesson one, don't do that because you haven't really covered it. So the reason for these exercises is to practice what we just covered during the lesson. If you find a question, which I believe I removed them already, but if you find a question that's telling you to do something and you can't think of any possible way of how to solve it without using a concept we haven't covered, then let me know and I'll check it out. But I'm pretty sure I removed them. It used to be where some of these exercises were asking you to use for loops pretty much. They gave you no other option. I'm pretty sure I removed most of them before the start of this course. But try to stay within the means of what was covered within this lesson. But all right, now we are done with day one's lesson, and we can move on to today's official lesson, which is going to be Python conditional statements and functions. All right, so conditional statements. We're going to start off talking about how to use them with Booleans. Myra, thank you for the emoji. But you saw a data type earlier, yesterday to be specific, which was true or false, right? And where true and false really shine is when used with conditional statements. I mentioned that you typically want to use Booleans when you're trying to keep track of the state of something. And reason for that is because depending on what the state is going to determine what your next move is in your code, right? And like if you recall the code snippet from yesterday, or not yesterday specifically, Monday. By the way, I misspeak a lot of times. If I say yesterday or tomorrow, even though it doesn't align to our schedule, I do that all the time. So I do apologize, but I meant Monday. Uh, but I mentioned or I showed you guys the code snippet of the heater, right? Or if the temperature was a certain degree, we turned the heater on by setting it to true. Or if it was a certain top of degree or above certain range, we turned it off, or below a certain range, we turn it off, right? Really, we just changed the Boolean from true to false or from false to true, right? That's where Booleans really shine, right? Allowing us to keep track of a certain state and then do one thing or another, right? So here we are checking the type, and I believe I showed you guys this yesterday when using it on true or false, but it's going to return to you the type of data type it is, and this is going to return, oh, I don't have a kernel. I don't know why my kernel turned off. But here you see that it returns bool, right, which stands for Boolean. Um, so Booleans can be assigned to variables, or you can just check if something is true or false. You don't necessarily have to save them to a variable, but it's helpful, especially when you're trying to create a state, like is alive, right? You want to know if someone's alive or not. You can set that to true or false. Saving it to a variable gives you better context of what the Boolean is supposed to represent. So when it comes to Booleans, and if you come from JavaScript, you might be familiar with using true or false in lowercase, right? Uh, Here's one of those similarities that with Python and JavaScript, where it's not much of a change, it's really practically the same thing. The only thing that changes here is going to be the punctuation, right? So for the punctuation with Booleans in Python, it's just going to be capitalized true or capitalized false, right? That's the only difference between JavaScript and Python when it comes to Booleans. So you see here, we're trying to check the type of false. I'm already getting some kind of error here. You can see there's a squiggly line here, and it says false is not defined. Well, because it doesn't, first and foremost, it's not a Boolean. Because it's not a certain data type, it's going to interpret this as a variable, right? So because it's interpreting it as a variable, and I haven't saved some kind of variable called false lowercase, it says that it's not defined. So as you can see here, not only is it not a variable, but it's also not a Boolean. So if you want to use your Booleans like true or false, ensure that you capitalize them or you're going to get an issue. If you're used to JavaScript, this might be a little confusing at first. You might be getting some errors because you're so used to typing it with lowercase. Just make sure you just capitalize them so you don't get that error. Now, when comparing different values, we have certain operators. Just like we had operators for multiplication or just arithmetic in general, we have some operators for comparisons. And they're quite similar to what you learned in math, right? When you want to check if two different things are equal to each other, the way that we do that is by using the double equal sign, right? Not to get confused with the single equal sign, which typically refers to assignment, right? Whenever we are creating a variable and we're giving it a value, we've been using the single equal sign to specify that you're going to assign that value to that variable. The double equal sign is comparing, right? So if I wanted to compare two different variables like variable 1 and compare it to variable 2, then I would use a double equal signs, right? Now, the same way that you're able to compare if something is equal to each other, you're also able to compare if they're not equal. And the way that we do that is by changing one of the equal signs to an exclamation mark, specifically the first one, right? You have to change the first one. Let me zoom in a little bit, right? So if you want to check if something's not equal to each other, you want to use the exclamation equal signs, which typically in code stands for not when using an exclamation mark. Next, we have the greater than and less than, which once again, those are fairly similar to how we use them in math, right? The greater than is the arrow to the right. The way that I remember it is like like if a bully is bullying like a little kid, they're like pointing at him, right? So whatever's to the left is like what's bigger.
Looks like you got cut off, unless it's me. Oh, that's me.
Hello? Can everybody hear me?
Yep, you're good.
Awesome. So the way that I
You're
remember
good.
what greater than or what's less than, for those of you guys who've been out of the game for a hot minute, uh, you want to think of it like kind of like the bully, right? So the bully typically points down at the weaker guy, right? So whatever's to the left side of the this arrow is going to be the bigger because they're pointing towards the smaller side, right? And the same thing with the less than. Right? I'm not trying to insult anybody's intelligence. I just know that some people here, we all come from different ways of life. So we're able to compare if something's greater than or less than, and we're also able to compare if something's greater than or equal to, right? The same way that we use the not equal, we're going to use that same logic with the greater than and less than, right? So here we can see if it's something is greater or equal to each other. And then vice versa, we can check if something is less than or equal to. So here are our examples. All right, to check something equal to each other, we have two different integers here, 23 and 32. And we already know it's not equal to each other. So when we run this comparison, it's going to return to you a Boolean, right? We run it and I get false because 23 does not equal 32. If I change that first equal sign to an exclamation mark, I'm going to get true because 23 does not equal 32. This is a true statement. Therefore, I get true in return.
Roger, do you ever see the triple equal sign in Python used by
No,
people?
that was the next one. Thank you for bringing that up. JavaScript does have triple equal signs. And typically, what the triple equal signs refers to is, are they equal to each other? And are they also the same data type? Right? So you're able to compare the string of 3 to the integer of 3 to see if they're the same data type using the triple equal sign. You do not have that in Python. No. But thank you for bringing that up. That's a good point.
Yeah, got it. Thanks.
So there we go. That's one difference between Python and JavaScript. We do not have the triple equal sign. Well, Roger, how do I compare if something is the same data type to it too? We'll talk about that, how we can chain multiple comparisons in a little bit. So we saw here how we can check if something is equal to or not equal to. Now let's check if something is less than. Here we are saving the result of this comparison to a variable. So comparisons, as you may have already noticed, are going to return to you a Boolean. And that's very important to know, right? When you compare something to another, you're going to get a true or false statement back. So whenever you're doing comparisons, you essentially want to use that logic, whether you're getting true or false in return, to do something or another. So here we're saying is 450 less than 350, which we know is going to equal to false. So this should say false into Boolean 1, and then I'm able to print out Boolean 1, and I see that I get false back. So that comparison returned to me a Boolean, and it saved it at the same time into this variable, which I could then use later and print out. I'm able to also create variables with values, like we see here, num1 and num2. They each have their own individual integers. Once I save them to the integers, I can use I misspoke. Once I save them to their individual variables, I can use these variables to compare them to each other. Is num1 greater than num2? When it runs this, it's going to check the value of each one of these variables. Num1 holds the 8, and num2 holds the 6, and it's going to return to me a Boolean as well. And we see here that I get true because num1 is greater than num2. And I see we got a message, but it make a difference if you use bool instead of print. could you specify your question a little bit more, Donsky? I think that's how you pronounce your name.
If I was guessing the question, I'm gonna let him do that.
Okay. So what that looks like to me, at first glance, it looks like typecasting, right? So essentially, what that looks like to me is that you're trying to convert the value of this to a Boolean. But by default, this is already going to return to you a Boolean, right? When num1 is compared to num2, it's going to return true or false. So wrapping it around the bool's wrapper is redundant. And that's not the convention of how you would print something out, right? So I'm using the print statement so I can print it out.
If I could add to his question,
Sure.
and what I thought it was going to be, is that at least for us, while we're going into Jupyter Notebook, if I press play without adding print to num_1 is greater than num_2, it's still going to print true.
Yes.
Is that?
So
Ooh.
that's a Jupyter Notebooks thing, right? And I did mention it very briefly on Monday that if you don't wrap something with a print statement, it's going to print it out anyways. That's the only flaw to Jupyter Notebooks that I really dislike because it builds bad practices. The reason why I wrapped it around the print statement is to enforce the good practices that you need to use the print statement to actually print it out. Because if you try to do that, for example, if I say like this right here, right? I say 23 does not equal 32, it gave me true. But if I do that here, what was it? 23 does not equal 32. Notice that I didn't print anything out. Let me clear this.
And we will visually see nothing.
Yeah, you visually don't see anything. As I mentioned, that is the biggest flaw with Jupyter Notebooks is that if you don't put a print statement, it will still show it to you anyways, which is bad, which is why I encourage you guys that when you're coding, try to use a Python file because this will show you exactly how it's supposed to be written. Because if you get too comfortable doing it like this, you're gonna forget to use print statements. You're gonna be wondering like, why is it not printing out? Because you got so used to Jupyter Notebooks holding your hand and printing it out for you. But as long as you're aware of why that's happening, that's all that really matters for now. Just try to make sure you're don't forget that, right? Or just code in a Python document. Once again, I'm using Jupyter Notebook because it makes it easier for me to explain to you the curriculum and then run code at the same time, all in one page without me having to switch back and forth between two different tabs. That's the reason why I'm using Jupyter Notebooks. But just be aware of that flaw. Sound good? Awesome. All right. Membership checks. So membership checks is another very important concept to be aware of. This is something that you're going to be doing very often as well as Python, is you're going to check if something exists inside of something else, right? And we use that with these short keywords with in or not in, right? Which quite literally mean what the words mean, right? The in operator is going to check if whatever is on the left side exists inside of whatever is on the right, right? And same thing with the not in, right? It's going to compare what's on the left. Is it not in what's on the right, right? So whatever you put to the left and to the right, it's going to compare those two. It's going to check if one of those exists in the other. And let me show you how that works. So here we have a list of years where there have been blizzards, right? It's just a bunch of different years. Just really doesn't really mean too much to you. Just know that this is a list of years. Now, we're going to print out what happens when we check if 2017 is in the blizzard years variable. And in and a not in, the membership check itself is going to return to you a Boolean, just like the comparison operators. So what I should be able to expect back is going to be an either true or a false result. So when I check if 2017 is in the blizzard years, I get false. And if I look through this list here, I can tell that it is in numerical order, right? It's ascending. So let me go all the way to the 2000s. And I see here, I get to 2015, and the next one is 2018, right? There's no 16 or 17 in here, right? So this is correct. 2017 does not exist inside of here, right? So I'm able to check if something is inside of another, right? So just like the operation description showed you here, whatever is on the left, right? That's what we're checking to see if it exists in the right, right? And then same thing if we were to use not in. If we check if 2017 is not in blizzard years, this is going to return true because it doesn't exist in here. That is correct, right? So the membership checks, the not in and in, allows you to check if something exists in something else, which is very important, right? This is a very useful concept that you're going to find yourself using pretty often when writing your code. Logical operators. So we talked about comparisons. We talked about not in. Now, what if we have multiple things to check? Well, we're able to chain them together, or I guess combine these different expressions by using and, or not. Now, for those of you who come from using JavaScript, you might be familiar with the double ampersands or the double pipe symbols to check and or, right? Python, as I mentioned to you guys before, is more English oriented. So it quite literally is going to use the words and or, right? So and is going to check if two statements are both true or both false. Or it's going to check if one or the other are true or false. And the not operator checks if something is not something. All right, and let's see this in action to make it make a little bit more sense. So here we have two different logical operators. We're checking if 10 is greater than 8 and 23 is less than 25. What do you think I'm going to get in return?
Should be true.
Yeah, you get true.
Absolutely, I'm going to get true, right? Because both of these equal to true. Now, if I say 23 is greater than 25, this is going to return to me false, right? The and operator is specifying that both of these have to equal the same. So if 10 is greater than 8 and 23 is greater than 25, then I would do the following. Todd, I believe you have a hot mic. So the and operator, you want to be a little careful with it, right? You want to use the and operator only when whatever you're comparing are all going to equal to what you're looking for, right? And same thing with whether they're less than or greater than, right? If either one of these, the left or right, fails, then the whole thing fails, right? When using the and operator, everything has to pass. So here we have another comparison. We say 9 in, and we're checking a list of numbers, or W in, and we see here it's a string, which seems to be a coordinate. So we're trying to check if 9 is inside of this list or W is inside of this list. And this is how the or is different than the and. The 9 does not exist inside of here, but the W does exist inside of the string. So because at least one of these passes the comparison check, we're going to get true, right? Because here we're not saying and. Doesn't matter if both of them are passing. At least as one of these pass, then the entire check will pass, right? So the and the or operator is going to be dependent on what you're looking for, whether you want everything to make sure it's true or false, or as long as one of them passes, then we're going to do the following. So here we have another one, and here's the not operator. So first, because we have parentheses, we're going to tackle what we have in parentheses first when this code runs. When this runs, it's going to check 4 not equal to 5, which is going to give me true, right? Because 4 does not equal 5. But because we prefixed it to the not, this is going to negate that and give me the opposite. So not true is really what it's literally saying. So when I print out Boolean 2, I get false, right? Although 4 does not equal 5, that's correct, right? It passes because I prefixed it with a not true, it's going to change it to a false, right? So it's doing the complete opposite.
Like a double negative.
Yeah, it's like a double negative kind of.
I say so on that one, why is it not able to do I guess concatenate, not really concatenate, but not and then how come it doesn't say not false and it leaves out the not?
It's not. How do I say it? It's doing an action. So it won't print out the not. It's just going to give you the opposite of what your result is. I don't know if that explains it well. That might have not been the best explanation. Um, you're just quite literally specifying, hey, convert this to the opposite of what I'm getting back. That's
Okay.
really what this is saying.
Gotcha. Okay.
Now, here's something that you have to keep in mind when working with.
I have one more question for you.
Yes.
Why is it for Boolean 2? Why did we put print for Boolean 2, but we didn't put print for the two prior strings, like the 30 or 27?
This goes back to what I mentioned earlier. That
Just building the habit correctly.
so I should get better at doing it. I don't always do it because I know that Jupyter Notebooks is going to print it out anyways. But I should have done this for good practice because that's how it's supposed to be done. But there's no specific reason why I didn't do it. It's more because I'm lazy and I know Jupyter Notebooks is going to print it out. But I'll get better at it because it looks like it's causing more confusion than anything else by not doing it. So I apologize.
No problem. But so there's really like no reason that we should ever not have print and then the line.
Yes.
Okay, gotcha. Understood.
That's perfect. Yes. There's no reason why you shouldn't have it. You should, to ensure that you are sticking to how you should be coding in Python, because when you start coding in a Python file and you don't add it, it's not going to print it out. I was I was getting complacent and I apologize. That's all me. But yeah, you're absolutely correct. You want to put print. No problem.
Yep.
So picking off from where I left off, when working with Booleans, you want to be a little careful as well with incomplete Boolean expressions. Now, what does that mean? Well, here I have 2014 and 2018 in Blizzard years. So this is going back to the same list here earlier. That's what it's checking. It's checking for 2014 and 2018 to be present inside of Blizzard years. But this is not a complete Boolean expression, right? It won't know how to read this. A complete Boolean expression, if you're going to compare multiple things, both sides, both the 14 and the 2018, need to have the comparison, right? Because when you forget to compare both of these to Blizzard years and you try to um, cut corners, what's going to happen is this is going to return true, right? Let's see. Is 2014 and 2018 in Blizzard years? Let's try. We see here 2018 does exist in here, but 2014 is nowhere to be found, right? There's a gap between 2010 and 2015, right? So it actually didn't check for the 2014, but it still returned true to me, right? It returned true, but it's not supposed to return true because both of these don't exist inside of Blizzard years. But for some reason, it still returned true. And the reason for that is because I did not complete this Boolean expression. It returned true because this one passed, but this one wasn't complete. So it didn't even check for this one. So it might give me a false reading. So when comparing things inside of other stuff, if you're chaining different comparisons with ands, then you want to make sure that both sides of the expression are complete Boolean expressions like this. 2014 in Blizzard years and 2018 in Blizzard years. And now this will successfully check for both of them. And now I get false. I get false because 2014 does not. Even though 2018 does, I'm using the AND operator, so that means both of these need to pass to give me a true Boolean. But because both of these do not exist in Blizzard years, it's going to give me false. Before it didn't give it to me because I did not complete the Boolean expression for the 2014, right? I was cutting corners, right? I try to shorthand it by saying 2014 and 2018 in Blizzard years, and that is an incomplete expression, and it won't know how to handle that. So be aware or be careful with your Boolean expressions. Yes, Dan.
So it wouldn't give you an error code if you just put 2014 and 2018 in?
No, it won't. That's why you have to be careful with your Boolean expressions. All right. And here's the correct way of doing it. All right, cool. But I already talked about this part, so we're not gonna waste any more time. So we talked about comparison operators. We talked about membership checks. Now let's talk about if-else statements. So if-else statements give us the ability to check for multiple different things. And we saw a quick little sneak peek at this yesterday with that heater snippet that you guys saw. But here we have a code snippet where we have a variable that holds the integer of 70, right? And this is supposed to represent the temperature. Now, if the temperature is less than 32, then we want to print out that there could be a chance of snow. But if it's not less than 32, and chances are it's not going to snow, so we should say there's not going to be any snow, right? So what we did here is we are using an if-else statement to check for two different possible scenarios, right? This allows me to go through two different routes depending on what comes back from my condition. So, as we already know, comparison operators are going to return a Boolean to me. So this is saying if temperature is less than 32, then I want to print this line. If this comes back as false, then it's going to default to the else statement. And instead of running this line here, it's going to run the else statement. All right, so you're able to have two different possible scenarios depending on what returns back from your comparison, right? Does everyone understand what this if else statement is saying?
So far, so good.
Okay, awesome. So the if else statement really, it just gives us two different optional possibilities of doing different things. Now, just like we were able to compare two possible scenarios, we're also able to add multiple different options using the elif statement. So up to now, we have the if statement, the else statement, and now we have the elif statement. The elif statement is really just short for else if, right? Let's read through this. So building upon the previous scenario, we have the temperature that's equal to 70. We're going to check if temperature is less than 32, then I want to do everything inside of this code block. And we'll talk about this other if statement in a little bit. Let's just stay at the high level for now. So this if statement, if it passes, we're going to run everything within this code block. Notice that what we want to run in the event that temperature is less than 32, that's being added inside of a code block, right? We start that code block using the colon, and then we go to the next line. It's going to indent it to the right. So what this means is this part right here, this piece of code, it only exists and is only going to happen if this if statement succeeds, right? That's why it's indented to the right. This only exists within this if statement in the event this one succeeds. Now, if our temperature is not less than 32, which is true, it's not less than 32, it's 70, then it's going to fail, and this piece of code will never run. And it's going to go to the next statement, which is going to be elif. So if temperature is less than 32, then do the following. Else, if temperature, and notice I said else if temperature is less than 55, I want to run this code block. But it's going to fail as well because our temperature is 70. So if this one fails and this one fails, we're going to default to the else statement. So it's going to print out looks to be a nice day. So we have three optional situations that might happen depending on whatever temperature is, right? And it's going to go from top to bottom. Now, hypothetically speaking, let's say our temperature was 15. And we run this code. It's going to get to the first line. And it's going to check, hey, is your temperature less than 32? And it's going to pass, right? It's going to return true. Therefore, it's going to run this code block here. But because this passed, everything else is never going to run, right? Because there's no reason to. We passed this check right here. So everything else is irrelevant, right? So be aware of that. Same concept if we had it before, right? If this doesn't pass, then if this doesn't pass, we don't care for anything else within here because it failed anyways, right? I don't care for anything else within here because I failed the check anyways. So we're going to go ahead and keep tracking on, right? So the if, elif, and else statement allows us to have possible routes of what we want to do depending on what comes back from our comparison.
So
Now,
I have a question.
I
What happens if you actually want to have more than one of the if statements run? How would you actually format that?
you have another elif statement. Right? Obviously, this first statement doesn't make sense, but if you have more statements to check, then you just tackle on more elif statements, right? Make sure that the order of your if or elif statements are in an order that makes sense, right? You want to check what's most likely to happen, and then as every other possible scenario comes into possibility, then we start adding them on in order, right? So yes, if you want to add more possible opportunities or of different things to happen, then you would add it using more else statements. You
Yes,
try,
but what I'm saying, sorry, what I'm saying is, what if you want like an if statement to run and an else and like maybe another one on top of that, or is that not possible?
what do you mean? I feel like I'm not understanding your question.
Like if you want to have more than just one possibility run, like if whatever you're actually searching for fits into more than one category, so you want multiple statements to actually run at once.
Do I have an example of that? I do not. Okay. So let's say mm,
Make the temperature 9.
I'm gonna do something better. I'm gonna say has jacket is equal to false. So let's say if temperature is less than 32, and if I have a jacket, then I should be able to go outside, right? So I should say if temperature is less than 32 and has jacket is equal to true, print I am going to go outside and play in the snow, right? So that's if not only is it less than 32, but if I also have a jacket. And I can say if temperature is less than 32 and has jacket is equal to false, print it is too cold outside. I'm staying indoors and watching cartoons. All right, something like this. Is that what you're referring to? Like if you have multiple different condition statements here?
I guess what I'm referring to isn't really possible since it's only going to take like the first instance where it actually matches, and then after that, the if statements just totally stop. So it doesn't seem like what I'm referring to is actually possible.
I could be wrong, but she might be referring to nested looping.
Maybe not nested looping, but probably nested if else statements, which is the next part of this, right? Um, which is this right here. So if it is equal to 32, we can come into this code block and then we can do a bunch of other else statements within here. Right, so not only can we pass this if statement, but we can have other optional statements that we have to also pass in here of multiple different options. And that's kind of what's happening here. If temperature is less than 10, I want to print it's dangerously cold outside. Else, print it is literally freezing outside, stay inside with jam mixing hot cocoa. So maybe this is kind of where you're trying to get at. So you could possibly pass this if statement and then also have additional other statements that you can do. And that's called nested if else statements, which is the next part of this conversation, is that you could, after you pass one check, have another layer of multiple other if else statements. Absolutely, you could do that, right? But what's important is first you want to pass this one, which would then bring you in here to tackle another set of statements, right? To, do multiple different other solutions. Does that answer your question, Monica?
Yes, it does. Thank you. And also Thomas too.
Awesome. Yeah, thank you, Thomas, for that. So yeah. So you are able to chain these if-else statements and do different things depending on what happens, right? So it doesn't necessarily have to stop here. You could come in here and add more if-else statements. So sure, we pass this if statement, but we might have a bunch of other stuff that we want to check for or have other possible sub-routes that we might want to take, right? So with that, let's go ahead and take our last 10-minute break of the night. It is 8 p.m. Let's come back at 8:10 and we'll continue with today's lesson. So the last part of the lesson where we left off is a student example. If you want to tackle it, you guys can. It says, how can we fix the code above to give us the intended response in the event our temperature is both below 55 and 32, right? Because as you may know,
Roger, we can't see your screen.
oh, thank you. I think is this one it? Okay, there we go. So, let's go ahead and come down here. So you will typically see logic trees constructed like the one above, starting with if, then elif, right? Short for else if, and a final catch-all else for anything not evaluated as true with the previous block. But there's an issue with some of this code. Let's look at this one. Right here, our temperature is negative 60. And when we go to these if-else checks, if temperature is less than 55, I want to print out layer up and stay warm. If it's less than 32, I want to print this out. If not, I want to print out looks to be a nice state. But what do you see that could possibly be an issue with the way this code is formatted?
It'll stop at the first one.
Absolutely. Yeah, it's going to stop at the first one. Because both these are true, right? So
Right.
I don't know if there's a mic. But so negative 60 is both less than 55 and 32, right? But ideally, it shouldn't trigger the first one. I might want to trigger the second one because it's even less than 55. So you might want to be careful with the way that you structure if else statements to ensure that it only matches what you want, right? So this could be a student exercise for you guys. Figure out how to make sure it only triggers if the 32 is an optional optional selection. Give me a second. Okay, sorry, I got a message. So I'll leave this for you guys to figure out, mess around with the code block to make sure it only triggers the 32 instead of the 55. All right. So finally, the second part of class, which is we only have like 50 minutes for it, but that's okay. We're going to talk about Python functions. So functions, you already kind of got a glimpse of what a function is through all my talking and rambling. We saw an introduction to them already, right? All these methods that we have been discussing, like dot upper, dot capitalize, these are really just built-in functions that are already built into Python, right? What are functions? Well, functions, really, it's a way to consolidate your code into one location and allow you to reuse your code, right? What's a good way of explaining that? Well, let's look at this method here on the example, right? They're using the capitalized method, right? If you are manipulating data, right, you have this long file of multiple names, whatever, and you're having to ensure that they're all neatly formatted to the same standard. Because let's say whoever used to be in charge didn't know what they were doing, and they just allowed people to input whatever information they wanted to. So we probably have maybe different standards. There might be people's names on our system that are capitalized, some aren't, some might be in all caps. It would be very tedious to have to go through every single one and then manually change the capitalization for each one of them, right? So it would be pretty useful if we could make something, right? Write some kind of code that can automatically take in information, format it for us, and then do the job for us, right? Instead of us having to manually grab every single name and manually capitalize it or manually format it, if it's going to be code that we're going to be reusing over and over again, there's probably a better way of doing it, right? And that's where functions come into play. When it comes to coding, we try to abide by a certain rule, which is the dry rule, right? Which is an acronym for don't repeat yourself. If you find yourself in a situation where you're constantly writing the same piece of code over and over again, it's probably a good idea for you to create a function to do the code for you. Not only does that allow you to save time on writing the same piece of code, but it's going to format your code a little bit easier so it's not an abundance of code, right? It might shorten what a program might be 300 lines of code to 200, right? So if you find yourself reusing code that might take like 5 different or 10 different lines to do a task, maybe it's just best to write a function where you only do this operation once, and then you call that function whenever you need it to do the hard work for you, right? That's really where functions shine. And that's kind of how all these other functions come into play, right? Dot title, dot split, right? These are methods that were created because these are very common things that people use day to day that are beneficial to probably having a function so you don't have to manually code it out every single time, right? And that's what these methods like capitalize, upper, dot split, dot lower really are, right? They are code that has been consolidated into one specific location that allows us to run it over and over again without having to manually type out the code every single time, right? And it's as simple as just calling the function like we see here. Now, let's talk about how we can recreate that, right? So I got a message here. Alex asked, why the open parentheses at the end of capitalize? Would someone ever pass any argument through it? That's a good question. So when it comes to methods or functions, you don't necessarily need to have any kind of content to be passed in for it to work, right? The parentheses are there. For one, it specifies that it's a function, right? But also it gives you the ability to give it some form of data to do stuff with, but it doesn't necessarily need it to work. There are some functions that don't take any kind of input and still work, right? So we'll be creating multiple versions of that. Right? So what do functions take, right? Functions can take inputs, and these inputs, when we are declaring the function, and when I say declare, I mean like when we're creating it, when we're defining what a function should be doing, we define what we call parameters, right? The parameters are really just what data or function should be able to take for it to work. Not every function, as Alex just stated, requires data. Some functions don't need to take any kind of input for them to do something. But if your function does need some kind of data, then that's where you would set it. You would set it in the parameters, and I'll show you how that works. Right? These parameters can be whatever you desire, right? It could be integers, it could be strings, it could be floats, it could be anything, right? When you are defining the function, you can name them whatever you want. Very similar to how when you create a variable, you give it a name that's relatable to what it should be holding. When you are creating the parameters, you might want to give it a name that lets other developers know what should be going into that parameter. Now, how do we define a function? Well, to declare, or I'm sorry, not declare, to define a function, we're going to use the def keyword, which is short for define, right? And we see that here. Here's an example function, right? The def tells Python, hey, I am defining a new function, right? I'm creating this from scratch. Right, after the def keyword, the def keyword, you're going to give your function a name, right? Just like you give variables names so you know what they hold, You give functions names so you know how to call them, and the function name should be something that's relevant to what it should be doing. Right? If I have a function that should be adding numbers, I shouldn't name it something crazy like, I don't know, make a cake, right? It should have something that's relevant to what the function should be doing. Now, after you give the function a name, you're going to open and close parentheses. This is where you're going to define the parameters that your function should be taking. As I mentioned before, a function can have 0 parameters, or it can have as many as you want to give it. Right? This specific function has 2 parameters. One is called num1, and another one is called num2. Now, there's no actual specific limit to how many parameters a function can have, but ideally, you want to make sure it's not an overwhelming amount of parameters, because at that point, that function becomes kind of annoying, right? If you have a function that you have to pass 100 parameters, that's that's a little overboard. So you don't want to do that, because at that point, it becomes very tedious every single time you use that function. Right. At that point, you might have to find a better way to kind of split up the workload into multiple different functions if you're having to pass in so many different parameters in there. Now, with this function in mind, right, this is how we initiate it. After you use the def keyword, you give it a name, and you establish the parameters. You're going to end it with a colon to specify that you're going to open up a code block to add the definition of what your function should be doing. Right? We're going to give it essentially the inner workings of our function, right? The logic that should go behind how my function works. So here you see an example, right? This function is called total sum, and as I mentioned before, it takes 2 parameters, num1 and num2. What do you think the values of num1 and num2 are? They're integers, right? Hence the name, num1 and num2. Inside of this function, I see here I have created a variable called sum, which is going to equal to, and this is a typo. They should say num1 plus num2. Let me change it. My apologies. Here you have a variable called sum that's going to take num1 plus num2, right? Once again, this is the definition of the function, right? We are defining what the function should be. There's no actual value saved or given to num1 and num2, right? This is very abstract. It could be any kind of number. It could be 1, it could be a million. The point is, there's going to be 2 different numbers that will be added together, and they're going to be saved into a variable called sum. Now, let's see it in action. So here we have my code block. I define a function called total sum, and I established that it should be taking 2 different variables. I'm sorry, not variables, parameters. Num1 and num2. Right? Num1 and num2 are going to be added and saved into sum. And then this function is going to print out the sum. Now, to actually use this function, you're going to call the function by its name. You're going to open up the parentheses, and then you're going to pass in the information that it needs for it to work. Because when we were defining this function, we specified that it needs to take 2 different numbers, num1 and num2. It's going to expect for you to give it 2 different numbers. If you don't give it 2 numbers, you're going to get an error because it doesn't know what to do because it's missing information. All right, so let's give it a try. When I run this, the first one works, right? It took in 2 and it took in 3. It adds it together, which is 5, and saves it to sum, and then it prints sum. And I see here that it did print out 5. Now, the second time I use this function, I only pass in 2, but I forget to give it a second number, and then I get an error, right? And it shows me here my error. It's pointing to where I got the error. And you see here, it's the second function call. And it says total sum missing 1 required positional argument. And it tells me what argument I'm missing, which is num2. Right? So whatever you define your function, you have to make sure that you pass in the information. Does anybody have any questions on how functions work or how you declare them?
So I do have a question on like if you want it to be multiples instead of just two numbers, do you just do the open and close brackets so it does as many or just
Like
keep
this?
adding?
Yeah, you keep
Well,
adding more parameters.
I figured instead of adding, right? Because you were saying like it would make no sense as to add so many of them in there. Is there a way to, so I guess not, right? Like it would make no sense to just say sum of open and close parentheses, like
That's
not
a good
include.
question. So how could we do that? Well, just like Myra said, what if I have multiple numbers I want to add? How would I do that? Well, that's where other data structures come into play. Now, we haven't covered it yet, but I can show you what I'm referring to. So here I'm going to create a list of numbers. List of numbers. We haven't covered number lists yet, so that's why I didn't want to get to it yet, but you asked a question, so I'll answer. This list has 1, 2, 3, 4, 5, 6, 7, 8. 8 different numbers in here. Now, if I wanted to take multiple numbers like this, well, without having to pass in multiple different variables like this, like I showed you earlier, num3, num4, what you would do is you could just take in one parameter, and we can call it list of nums. And within your function, what you can do is, and like I said, we haven't covered this yet. We haven't covered for loops, but I would iterate through these numbers. I would create a variable called sum. I would say for num in list of nums, sum plus equals num. And what this is going to do is going to iterate through the entire list, grab each number, it's going to add it to my sum. So this is a way of doing it. And like I said, it's out of scope. So I understand it's a little confusing, but you asked, so I will deliver. And here it is. This is one way how you can take multiple different arguments without having to specify each individual parameter and having a long list of parameters. Right? Does that make sense to you, Myra? Awesome. So back to our current code. So let's go ahead and remove the print statements. And let me go ahead and run this. Oh, let me comment this out. The only function that's going to run is the first one, total sum 2, 3. What do you notice when I ran this? Nothing prints out, right? Well, if you want to print out something that happened inside your function, you're going to want to wrap it around a print statement. Usually, when you want to do something like adding numbers and then use that numbers in the rest of your code, you typically want to be able to grab the numbers and bring them out of the function so you can print it out, right? Right now, as it stands, this function isn't giving me any kind of data. When I wrapped it around the print statement, notice that I got none in return. Why is that? Well, currently, this function does not return anything to me. Sure, it added num1 and num2, and it saved it to its variable called sum, but sum only exists within the function. It does not exist outside of it. So, Roger, how do we get access to this? Well, if you want to grab information from the function, you have to return it to the rest of your code by saying return sum. And now when I run this, I see that I get 5, right? Now you're wondering, Roger, why do I have to do that? Well, that brings me to another subject called scope. Local and global scope, right? What is local and global scope? Well, it's referring to where you are working in your code, right? Whenever a function runs, we quite literally go inside of this function and start working. When the function is done, we exit out of the function and go back to the global scope of our code, right? So the inner workings of a function is really like its own little compartment, right? It's like a room where it's doing everything. It's like in a restaurant, the food that's being done in the kitchen, that's the function, right? The kitchen itself is the function. The chefs inside the kitchen that are cooking is the function working. Once the food is done, if I want to have access to the food and eat it, I have to bring it out of the kitchen. Same concept here with functions. When the function runs, it's going to do what it was programmed to do, but I have to manually bring out the values to the rest of my code for it to have access to it. And because I didn't have a return statement, when I tried to print out what came back from my function, I got none because there was no data.
Okay,
Right?
so the way I look at this would be like, defining the function would be like naming the recipe, like this is the recipe or whatever. And then the parameters would be like the ingredients of that recipe. And then how to cook that recipe would be I guess, the
The definition of the function.
the,
Yeah,
ve- the definition. And then printing it would be actually making the recipe or whatever. So like if you want to, I mean, you have the ingredients, you have the directions, but if you want the platter, you'd have to print it,
Yeah, if you want to grab it or look at
Gotcha.
let's say you're making a cake, right? You create a function or a recipe for a cake. The parameters are the ingredients this recipe requires for it to work, right? But once you're done making the cake, if you want to see your cake, you have to print it out, but you have to return it, right? So yes,
What if,
you're on the right track there.
what if you took out your variable, like I kind of put it in the chat there, and instead of having a variable called sum, you made the function print, and then you just called the function later? I tried it in the practice and it worked. I was just curious.
So your function right now, it's gonna take two numbers and it does print it out. But the issue with that is, and I'm glad you said that. Let me show you. So if I do exactly what you did, and instead of printing it outside, I did in here num1 plus num2, right? And I tried to do something, let's remove all this stuff. And I want to do print. I'm going to do 5 plus total sum, right? This won't work because this function returns none to me. So I can't use the values inside of the function. Nothing comes out of it. Sure, did it print it out? Yeah, it printed out. It added it and printed it. It didn't save it anywhere. And it didn't return to me the value. So I can't use the information that is in the function because I never returned it out. So that's why you don't want to do that, Andrew.
Okay, cool. Thank you.
Yeah, no problem. So it will
So
print it out,
using
guys.
so returning it makes it possible to use it globally
Yes.
elsewhere in your code.
Yes, returning it gives you access to the ability to use it globally and assign it to a variable. So that brings me to my next point. If I did this, I could say sum of nums is equal to total sum, and I'll pass in 2, 3. And I can say print 5 plus sum of nums. And this will work. Because what's going to happen is I define my function, which is going to add 2 numbers, save it to a variable, and it's going to bring back the variable back to the global scope of my code. So when I run this function, this is going to return to me the sum and it's going to assign it to this variable. And I'm able to use it now.
Could you still do that without assigning it to a variable since you returned it anyway? Like, could you
I
just do
could,
print 5 plus total sum 2 and 3?
yes, but if I want to use it again later on, it won't be saved anywhere. I'm gonna have to call it again. And it kind of defeats the purpose. Like, why am I constantly calling it? I would just save it somewhere so I can just use that variable.
Yeah, got it. I just was curious out of for like syntax rules purposes if it would let you.
Yeah, this will definitely work. But ideally, if you're making your function do something and return to you a value, you want to save it in a variable that's in the global scope of your code so you can use that variable over and over again,
Got it.
right? So I know I just dumped a lot of information for you guys. We're about to kind of cover it one step at a time throughout the remainder of this class. Roger, can you explain the importance of having the return with the correct indentation versus having the return at the same level as the function? So the code blocks, the indentation, all part of the syntax of Python and very important. How does Python know where the definition of my function starts and ends? That is all dictated by this indentation. Everything that's indented underneath this is a part of the definition of my function. If I do this, I am no longer within the local scope of my function. I am now back to the global scope, right? The local scope is everything within this indentation underneath the function. So indentation matters a lot, right? So that's how like you separate where a function starts and it ends. And I see some comments about JavaScript. Uh, JavaScript will do something like, I think it's function, and it is like total sum, num1, num2, and then it would open up parentheses, I'm sorry, curly braces like this. This tells you where it starts and it ends. You don't do that in Python. How do you know where it starts and ends? By the indentation, right? So after this colon starts, we indent, and everything after the colon that's indented is a part of the function. When you're ready to start going back to the regular scope of your code and continue coding, you want to unindent. Now you are outside of the definition. You are no longer within the local scope of your function. Does that make sense to you, Angel? Awesome. All right, let's continue. I'm gonna elaborate a little bit more on this stuff. I kind of just dumped everything there at one time, so I do apologize. So here's another representation of that sum. I'm sorry, the return statement. The return statement is used to specify the value that a function should return. It is optional, right? And a function could return none. You don't necessarily have to make it return anything to you, right? But if you want to have access to the values that come from that function, you have to return it. You're not going to get an error just because you don't return it. That's fine. You don't have to return it. But if you want to have access to it, then return. If the return statement isn't used and you attempt to save the answer from your function, you will come to find that the value would hold none. Right? We see here, this does not have a return statement. We're calling the function and we're assigning it to sum. But when we print out sum, it has none. Because by default, the function is going to return none unless you tell it to return something else. Right? So that capitalized method that you saw earlier that we talked about, there is some actual code that goes behind it. So this is my version of how the capitalized method should work. This capitalized method, I hard coded it, right? I created capitalized underscore name, and this takes a variable called target name. I grab target name, and I specifically grab index 0, and I use the dot upper method to capitalize the very first letter of this string, and I save that result into this variable called capitalized letter. And like I mentioned to you guys before, you can't mutate strings. So if I want to create a new formatted name with the capitalized letter, I create a new variable called formatted name. I grab the capitalized letter I created, and I'm going to conjoin it with the name that I was passed in, but I'm only gonna grab everything from index 1 to the right because I no longer need index 0, right? Because we don't need that. I'm trying to add the capitalized letter to the left of it. And here you see, here's my name, and then some additional ones here. And when I run this pre-built capitalized name method, it does as such. It capitalizes the first word of that string, right? So that's quite literally how that capitalized method is working, right? Somewhere in Python's, files, this is how it's written similarly, right? It's not magic, right? There is some code that's doing this heavy lifting for you. Now, if I had to capitalize multiple things over and over again, every single time I would capitalize something, I would have to do like 3 or 4 lines of code, and that's not ideal. Once again, this is where functions shine. It allows you to create a function that's going to do all the heavy lifting. You define it only one time, and then you can use it as many times as you want throughout your code, saving you some additional space of wasted lines. Here's a custom find method, right? If you guys recall, actually, I don't like this one. I'm gonna skip this because it's still using the original find method. But this is from the old instructor that taught this one. So then this next section talks about function scope. I'm also going to skip this one because it is a lot. It's very overwhelming. And it's very easy for me to lose you guys. If you want to dive through the code and try to make some sense to it, I encourage you. If not, that's okay. But essentially what this is showing you is how we are able to change stuff inside the local scope, but it doesn't affect the global scope, and then vice versa, right? In short, let me draw it out for y'all instead of going through that code demo. Here's my code file, right? The exterior, the entire code file I have is the global scope of my code, right? This is what you see here. All of this, the exterior, everything that's not indented, right? Everything's the far left. That is the global scope, right? Now, somewhere in here, I create a function. Right? This function is the local scope. Oh, Lord. I suck at this. I'm sorry, y'all. Right. What's inside the function is the local scope. It's local to that function. If I have a variable called, let's say, number 1 is equal to 0, or let's say 5. Number 2 is equal to 10. The local scope has access to everything within the global scope, right? My local scope can access everything outside. Kind of like you guys. Y'all can go outside your house as much as you want. Everything outside, you can bring it in, right? You can bring it in, you can have access to everything outside. But let's say you make dinner. Does your neighbors have access to what you create in your home? Heck no. Only if you want them to, right? But by default, whatever happens in this local scope or your house, that's yours. Nothing out here can touch it, only if you want it to. And that's done by the return statement, right? So the local scope can access everything within it and outside. The global scope, the people outside, they can have access to everything outside, but they do not have access to anything inside unless you give them the ability to using the return statement. All right, so the global scope represents everything in your code that's not indented. Once you get into the function and you go like indented in here, this is the local scope and this is your global scope. Right? Does that make sense? Awesome.
Yes, yeah.
That's just the best way of explaining it without going to the headache of a code. I should probably remove this one. All right. So here is another way of seeing it. Notice that this function, inside of this function definition, we declare a variable called x and assign it 10. We print it out, right? This says printed inside function, right? And it does. It prints it out. It prints out the string and x, which is 10, when we call the function. But when we try to access that variable that was created in here, we get an error. It says it's not defined because the global scope of our code does not have access to this variable that was created in here. This only exists within my function. Once this function is done running, nothing outside of my scope of this function has access to it unless I give it to it, right? Unless I were to say return x, right? And even then, I think I'm pretty sure I have to assign it to a variable. See, even after I return it, because it's not saved anywhere, and I try to call it, I can't use it, which is why it's important that you save it somewhere so you can use it. Unless I put the function call inside of here, and then it'll show it. But if I try to use it like a regular variable, I don't have access to it because they only exist within this function. So understanding the scope of your code and your function is very important. I say that because you're going to attempt to use, you're all going to do it. I just know it. You're going to try to access the variables within your function. You'll be like, Roger, it's not working. I'm going to look at it. I'm like, it's because you never returned it, right? It only exists within your function.
Wait, Roger, so I was completely tracking until you just showed us that example. I'm not understanding how you put return X, but we still can't access X outside of the function.
You can't access return X because where do we run this function? Right here. It returns it, but did we save it anywhere? No. Right? This function will run and it'll do the work, right? When this runs, it makes the variable X and it prints it out. That's how you see this here, right? And it returns it, but this is not being assigned. Whatever's returning here is not being assigned anywhere.
Okay.
So when we try to print it out, it doesn't know what to do with it. Like, I don't know. But if I did something like X is equal to what comes back from my function, then it works because I assigned it to a variable called X out here.
Okay, yeah, that's exactly what I was going to ask you to demonstrate next, to make it work.
That's my next question. Is this X the same as this X right here? No. This X here only exists the moment that this code is running. I don't have the explanation here. I thought it was a piece of code that did it.
Like a local X and a global X, but they're different variables because they're declared at different scopes.
Yes, because they're in different scopes. These are two different variables. As a matter of fact, once this code is done running, this X disappears. It doesn't even exist. It only exists the moment the function is running. So if you want to keep the value that's assigned to it, you have to return it and assign it into a variable outside of the function.
Got it. Got it.
All right. So print statements. You guys just think that it's just so we can look at our code. Print statements are going to be probably the lines of code that you're going to use the most throughout your entire career. Print statements are amazing debug tools, right? Because it allows you to visually see what your code is doing. Print statements are very helpful to see where your code stopped working. Let's say you have a function, it might be 50 lines long, who knows? And it fails. It can be very difficult to understand where the code fails. So what helps is to add print statements at different parts of your code to help you debug it, right? So as this code runs, it multiplies X and Y, and we're printing out this interpolated string to show me the result of that. So I see that it got up to this point successfully because I can print it out. It then uses the absolute method, which I don't think we've covered yet. Don't worry about it. The absolute method, it takes a number and it gives you the absolute positive value for it. So let's say you have a -5, it'll convert it to a +5. That's all absolute is doing. It prevents you from having negative numbers in general. So in the event this gives me a negative number, it's going to make it to a positive number and save it here. And then here is another print statement to show me that I've made it this far into my code, which it does show me. Notice that it went from -60 to +60 after this line. Right? And then we get to if product is less than 55, result is equal to this, else it's equal to this, and result or return result. But the point of this explanation was to show you that we're able to use print statements in our code to see how far our function got before it fails. Now, obviously, this function didn't fail, right? And you don't want to just start putting print statements all over your code. You don't need to do that. The only time you really need to do print statements in your code is if for whatever reason it's failing and you need to see where it's failing, you might want to go through your function or any part of your code and put some print statements to specify like, I am on line 55. So you can see like, did it ever print line 55? It didn't. That means my error is somewhere between line 55 and above, right? So it's very helpful to use to figure out where the errors in your code is located at. And that's going to conclude today's class. I know that was a lot of information. Functions can be very confusing at first. So I understand if you guys are a little confused right now and you don't get it immediately. For the remainder of this course, I believe all our exercises are going to ask you to make functions to solve them. So you should get enough practice. Because really, everything that you've been doing, like all this code here, I could put all of this in a function, right? Let me find something like a previous line of code. So here is, I'm quite literally just putting them in here. I'm gonna say notice that it didn't change the output. The output stayed the same. So functions, all you do with functions is you essentially put them in some kind of container that you can call to run it. Right? It is a way of formatting your code into one specific location so you can run it over and over again. Right? So this piece of code took 4 lines to create. If I wanted to run this 8 times, or let's say 5 times, it's easier to multiply, I would have to write 20 lines of code. But here, I can do this function 5 times, and it saves me 15 lines of code. Right now, obviously, this isn't the best example because who wants to do this 5 times? Makes no sense. But the point is that you're able to format all your code into one function and then run that function over and over again if you needed to at different parts of your code to keep you from rewriting the same code that you've already written multiple times, right? It adheres to the don't repeat yourself methodology. That way you write clean code, you save some space, and it's nice and neat. Now, notice here that this doesn't take any arguments and it still works. If it takes arguments, then you have to pass in the arguments, right? If you added the parameters. Some last minute things I want to talk about before I let you guys go is you are able to add default parameters. For example, let's say I'm going to set the second number to 3. I can say num2 is equal to 3. What that does is in the event I don't add a second argument, this code will still work, right? You can give a default inside the parentheses during your definition to give it something to fall back on in the event you don't want to add a second argument. That way it will still work, right? Let's say you have a function that by default, there's a certain argument that it should always be, but you have the ability to override it, right? So this works, it gives me 5, but I could say 10, and I get a different result. So if you pass in that second argument, it's going to override that 3, but in the event you don't pass anything in there, the function will still work, but it's going to use the default argument you passed in, right? So your definition of your function, you can give it the ability to give it arguments, or you can even set a default one if you know there's a specific value that it's usually going to be something. At a minimum, it should always be like 0 or 5 or whatever it must be, right? This is how you get some of those methods that there's it's optional to give it an argument if you want to, but you don't always have to give it something. It defaults to a certain value. That's how that works. Now, time is 8:58. That's going to conclude today's class. Let me go ahead and stop the recording.